we're going to go ahead and take a look at number 59 from section 1.2, which deals with application problems and linear equations. So if you don't have your book with you, please go ahead and pause the video and make sure that you have that out. Also, make sure that you have a notebook and something to write with. As I'm reading through the problem, I would like you to note down any important information that you feel you might need in order to help solve this problem. Okay, so for 59, a Johnson motorboat goes 5 miles upstream in the same time it requires to go 7 miles downstream. If the river flows at 2 miles per hour, find the speed of the boat in still water. So again, a lot of information kind of crammed into a small narrative, but start picking the problem apart and you might actually be able to wade your way through it, pun intended, since we're talking about rivers. So what we're going to look at, we are going to note that there are two cases here. One case that they keep talking about is upstream, and the other one is downstream. Okay, I'm actually going to go ahead and do upstream in this blue, and I will write the downstream in this pink. Okay, so for upstream, we know that the distance, we seem to be talking about distance and time and rate again. So I'm just going to go ahead and generically put distance is equal to rate times time above. That's going to help me kind of organize my information. I'm essentially creating a table. And we know that the distance upstream, it's going to be 5 miles. We don't know what the time is going to be in this case. We just know that the time going upstream and the time going downstream in this scenario are the same. So our time is just going to be labeled as t. Okay. We know that the rate is, since we're going upstream, we're going against the current. So we're going to actually be moving slower. The boat will be using the same rate of speed, but since the water is pushing against it, it's actually going to cover less ground. There's more resistance that's happening. So we would say here that my rate will be x minus 2. It's whatever the rate the boat is working with minus the 2 miles per hour that the current is taking away from the boat. So now we can go ahead and justify a similar argument for going downstream. We know that the distance that it's going to cover is going to be 7 miles. And this time, if it's going downstream, it's going with the current. So the current is actually pushing with it. So it's giving it a hand, in a sense. You know, it's kind of like if you are walking with the wind, how the wind almost pushes you and makes you walk a little bit faster. It's the same situation. So here, we would say that, again, they're going to use the same speed, but now the river is helping them. So we are going to go ahead and add 2 miles per hour to the rate of the boat. Okay. So what I want you to note here is that reread through the problem again. A Johnson motorboat goes 5 miles per hour upstream in the same time it requires to go 7 miles downstream. So this idea that they're giving you here, this in the same time, this is really saying time upstream is equal to time downstream. Well, in class we had talked about working with distance is equal to rate times time, and since this problem is explicitly dealing with time, let's go ahead and modify the formula so that we have distance divided by rate is equal to t. So now we can say time upstream will be 5 all over x minus 2, and this will be equal to the time downstream. So that would be the distance going downstream divided by the rate going downstream. That would give us the time it takes for the boat to go downstream. So this would be 7 over x plus 2. From here, that's the most challenging part of the problem, in my opinion. Because now, if you notice, you have a proportion here. You have one fraction equal to another fraction. So what this is going to permit me to do is I can use the shortcut of cross multiplication to help me out here. Okay. So this is going to give me 5 times the quantity x plus 2 is equal to 7 times the quantity x minus 2. And from here, hopefully it gets a little bit easier. Maybe you guys are feeling a little bit more tension leaving your shoulders. Maybe you're breathing a little bit more evenly now. Maybe you're laughing at me because I'm running on my sentences. So what we're going to note here is that we have 5x plus 10 because we're going to distribute that 5 into the quantity and give it to each term. And then we have 7 times x minus 2, so 7x minus 14. Okay, so subtract 5x from both sides to clear the x's on one side of the equation. Add 14 to the other side, or to both sides, excuse me. Let me be accurate in what I'm saying. And then we will be given 24 is equal to 2x. So if we divide both sides, then we are given that we have 12 is equal to x. And this actually is our answer. If you go back to your table, so I'm going to kind of highlight here, x was found in your rate. Okay, this is the rate of the boat itself. Remember, we were subtracting 2 and adding 2 to account for what the river was doing to the boat. But if we kind of removed that variable, then we would just look and see how fast the boat was making itself move. So this is your answer. This is 12 miles per hour. So the boat, whether it was going upstream or downstream, we had the boat moving at 12 miles per hour. And there it is. If you have any questions, please feel free to come find me.